In this video, we're going to talk about measuring angles and arcs. And our first term is central angle, and its definition is an angle with a vertex in the center of the circle. Its sides contain two radii of the circle. So if you take a look at the picture, I have the measure of angle ABC as being right here. And notice that the vertex of this angle is at the center of the circle, which is what central angle means. Now, let's say we had any number of central angles all around our circle, like so. The angles themselves all have a special, unique relationship, and that is that all of the angles will always add up to 360 degrees. And now that I've written it out, I think I may have said 180 degrees. They should add up to 360. I'm not sure if I said that or not. So anytime that you're ever wondering about solving for x or determining a missing angle, know that all of them, no matter how many there are, must have a sum of a circle, 360 degrees. Okay, so our first example is we are just going to simply find the measure of x by using our new knowledge of central angles. So notice in this picture we have four central angles. One is 85 degrees, one is x, one is a right angle, and one is 40 degrees. So to solve, we are going to set up an equation and set them all equal to 360 degrees. So we have 40 plus 85 plus x plus 90 equals 360. So we're going to add our like terms together, which are 40, 85, and 90, which we get 215. And now we are going to subtract the 215 from both sides. And we get 145 degrees. So that's all there really is to that. So next we're going to discuss the different kinds of arcs that we can have within any circle. And the first one is a minor arc. So a minor arc is an arc that's less than 180 degrees. So in the picture that I've drawn for you at the right, a minor arc would be this arc right here, and notice that an arc is part of the outside of the circle. And arcs can have degree measures too. They're actually equivalent to the degree measure of their central angle right here. Okay? Now, arcs have special notation. What we're going to do is we're going to say that the measure of arc, like a rainbow, AB, okay, is equal to the measure of the angle ACB. Okay, so those are two different ways to write it. The arc is written like this, and the measure of the central angle is written like this, and they should be equivalent to each other. Right, so major arcs are angles greater than 180 degrees. So we could use the same exact picture to see what a major arc is instead by connecting A and B in the opposite direction. So I could connect A and B like this, and this would be an arc that's greater than 180 degrees, and its central angle would be this angle right here. So we would name it the same way. We would say that this is the measure of arc AB, which is also equal to the measure of its central angle, ACB. So if you're ever given a situation where you could have two different arcs like this, you just have to know which one that you're talking about. And then, of course, the last one, the semicircle, is when we're exactly equal to 180 degrees. This is typically what makes up a diameter. So again, in my circle, I'll name the center C, but we are going to have A and B be on the exact opposite sides and go right through the center. So this would be exactly 180 degrees. And of course we could have the arc that's down here below or the arc that's up here above. And it just depends on which one that you're talking about. And of course, the measure of, again, arc AB is equivalent to also its central angle, which we would name the same way. So this is ACB, and in this particular case is also exactly equal to 180 degrees. So we're going to take a look at a small example here which says to identify each arc as a minor arc, a major arc, or a semicircle. And our first example is going to be the measure of GH. And my apologies, we do not need the measure here when we're just identifying. So when we take a look at GH, we typically talk about the closest distance between those two letters. So when I look at GH, I would not go in this direction to connect them. That's not the shortest distance to get between G and H. The shortest distance is to go in this direction. So that's the arc that it's talking about. Now I'm going to call this a minor arc because I know that it's smaller than a semicircle, and a semicircle would be exactly 180 degrees. So that is a minor arc. The next one is going to be arc GLH. And typically, if you ever see an arc being named with 3 letters, it's helping you go into a particular direction. It's telling you to go from G to L all the way to H. So this whole entire blue arc is what it's talking about. That is definitely going to be a major arc. It's larger than 180 degrees. It's larger than a semicircle. So the next one is going to be GLJ. So when I take a look at GLJ in this picture, again, it's giving you 3 letters to have you go in a particular direction. Connect G to L to J. Now, when I take a look at that a little bit closer, I know that this is going to be exactly a semicircle because this part, the part that's connecting G to J, is a diameter. So that would be a semicircle. So next we're going to talk about some congruent arcs, and that's basically just arcs that are in the same circle or within congruent circles that have the same measure. And in this particular circle, we can see that we've got a couple pairs of congruent arcs. We have the measure here, arc BC and arc CD are congruent because they have or will have the same measure. They're made up of the same percentage of the circle. And we also have F to E and A to F. And please keep in mind that this is a hand-drawn picture and my drawings are not always to scale. Using this same picture, if you were given a picture like this, and let's say each of these represented a sport that you played. So maybe this piece of the circle is for basketball, and this piece is for track and field, etc. What if I wanted to know what the arc of those measures are? So there's a way that we can do that. Let's say I want to know the measure of this arc right here from A to B. So in other words, I'm looking for this. Okay. So the way that we do that is we have to think about that 20% as 20% of an entire circle. And we know that the degree measure of an entire circle is 360 degrees. So we're going to convert 20% to a decimal, which is 0.2, and we're going to multiply that by 360 degrees, which gives us exactly 72 degrees. And this is how you could go about finding the arc measures of every single piece around this entire circle if you wanted to, if that's what the question was asking. Another new word that we have are adjacent arcs, and these are arcs in a circle that have exactly one point, which is not the center of the circle, in common. So if we take a look at the picture above again, I could say that arc AF and arc FE are adjacent arcs because they share the point F in common and nothing else. So those are your adjacent arcs. Okay, so we're going to now talk about the arc addition postulate. And all this says is that the measure of an arc formed by two adjacent arcs is the sum of the measure of those two arcs. So in this particular picture, say I wanted to know the measure of arc AED. And again, I'm giving you 3 letters because I want you to go in a particular direction. I'm talking about just one of these specific arcs. So we're going to connect A to E to D. So this is made up of the 2 separate arcs, AE and ED. So we could actually write this out as the sum of arc AE plus ED. So we're going to take this, the 2 measures individually, which is 63 degrees here, and this looks like a 90-degree angle, and we simply add them up to give us a sum of 153 degrees. And that's really all you need to do for that. So I'm going to add in one more part of this circle. I'm adding G, and that arc from G to A is now 51 degrees. And I'm going to ask you for the measure of the arc GAD. So now we're going to go from G to A, and we're going to stop at D. This is a good time to note too, even though there's more than one letter that I'm going to go through, so it would technically be GAED, we only use 3 letters at most to name an arc, and 2 at the minimum. So if this was my problem, I would take all 3 of those arcs and add them up together. So I would do 63 plus the 90 plus the 51, and that would give me my total angle. So that was the 153. And now I'm going to add 51 to that, which is going to give me 204 degrees. And that will conclude this tutorial.